All right, so get this. We're diving deep today into AI,
Ooh, fun.
but like specifically how to make AI way more accessible.
Okay. Yeah, I can talk about that.
Think like the power of a massive AI system,
Huh.
but like right there in your pocket.
Yeah, like on your phone.
Exactly. And that's where these one-bit LLMs come in.
They're pretty cool.
And we're going to be focusing on some exciting work from Microsoft Research and their BitNet architecture.
They're really leading the way on this.
So to set the stage, traditional large language models, those are impressive.
Oh, yeah. Incredibly powerful.
Okay.
They're really resource intensive.
Yeah, to say the least.
They use 16-bit numbers to represent all their parameters.
And that takes up a ton of memory and processing power.
They're trying to run.
A huge video game.
Yeah, like a really high-end one on like a 10-year-old laptop.
It just doesn't work well.
Nope, not at all.
That makes sense. So how do these one-bit LLMs change the game
Well, they're somehow slimming down the information.
without sacrificing the AI smarts?
They're using just 1 bit to represent the model weights.
Whoa, that's a huge reduction.
It is. It drastically reduces the precision.
And that doesn't hurt their performance.
Surprisingly, no, the performance is still really good.
It's like figuring out how to bake a delicious cake.
With way fewer ingredients.
And it still comes out tasting just as good.
Exactly.
Okay, now that's what I call efficiency.
For sure.
But how are they pulling that off?
Whoa.
Microsoft's BitNet architecture seems to be a key player here.
Absolutely. Microsoft Research has been working on this for a while.
Yeah, I've been following their work.
And their latest version, BitNet a4.8, it's a real breakthrough.
Okay, so A4.8 is the latest and greatest.
It is, they had earlier versions that used 1.58-bit values.
Still a lot less than 16.
Yeah, a huge improvement. But even those hit some computational bottlenecks.
I see. So even with fewer bits, crunching all those numbers was still a major challenge.
Yeah, it's like trying to solve...
Like a giant puzzle.
Yeah, but with tiny pieces.
Like each piece is the size of a grain of rice.
Technically possible.
But incredibly tedious.
Yeah, exactly.
So to overcome that hurdle...
They've incorporated 2 key techniques.
Okay, lay them on me.
Sparsification and quantization.
Huh. Okay, break those down for me.
Okay, so think of it like packing a suitcase for a trip.
Okay, I can visualize that.
Sparsification is like deciding to only pack the absolute essential.
You're getting rid of all the items you won't actually need.
Right, which frees up space.
Gotcha. And what about quantization?
Quantization is like using those clever packing cubes.
Ah, okay. To compress your clothes so they take up less room.
Exactly. You're essentially representing the information with fewer bits without losing the core data.
Okay. I'm with you so far. So sparsification is like choosing what to pack, and quantization is like packing it efficiently.
Perfect analogy.
But I imagine doing both of those at the same time is tricky.
Oh, yeah, especially during the AI training process.
It's like trying to pack that suitcase while you're still figuring out what you need.
Exactly. It's a tough challenge.
So how did they manage to do both at the same time with BitNet a4.8?
Well, they developed this hybrid approach
A hybrid approach.
to quantization and sparsification. So instead of applying these techniques uniformly,
They mix and match,
you got it. They strategically apply them to different parts of the model.
depending on what's needed.
Right. It's all about customizing the packing method for different types of information, making sure everything fits perfectly.
That's really clever. Can you give me a specific example of how that works in practice?
Sure. So they use 4-bit activations for the most critical processes.
So for the really important stuff, they use a bit more precision.
Exactly. Ensures accuracy where it matters most.
Okay, makes sense. And what about the rest?
Then they use sparsification on the intermediate states.
Okay, so they're getting rid of some of the data there.
Right. But they're keeping the most important 55%.
So it's like carefully folding your delicate clothes, but tightly rolling up your socks.
Yeah, to maximize space in your suitcase, everything has its place.
Love it. And what about those 3-bit values they're using?
Ah, yes, those are for the attention mechanism.
Remind me what that is again?
It's like the model's short-term memory.
Okay, right. It helps the AI focus on the most relevant information.
Exactly, and by using smaller 3-bit values for this part.
They save even more memory.
Especially when the AI is processing long sequences of information, it's like having a super organized filing system.
Makes it easier to find what you need quickly.
Precisely.
So they're really optimizing every nook and cranny of the model.
And they've managed to achieve some pretty amazing results.
It's like, how amazing are we talking?
We're talking a 10x reduction in memory usage.
Whoa.
And a 4x speed up compared to those bulky, full precision models.
That's huge.
It's like going from driving a gas-guzzling truck to zipping around in a sleek electric car.
Now that's what I call progress. But what does this all mean in practical terms?
Good question.
Like, how does this actually affect the way we'll interact with AI in the future?
Well, this incredible efficiency boost means we can start running powerful AI models on everyday devices.
Like on my phone.
Even your phone. Imagine having a sophisticated AI assistant right in your pocket, ready to help you with all sorts of tasks.
Okay, that does sound really cool, but wouldn't running complex AI models on my phone drain the battery in an instant?
That's the beauty of these one-bit LLMs. They're so efficient that they can actually run on low-power devices without compromising performance.
So no battery drain.
Not really, and because they can run locally, there's a whole new level of privacy involved.
Oh, right, because my data stays on my device.
Exactly. No need to send it to the cloud.
So it's like having a personal AI genie always ready to help without sacrificing your privacy.
That's a great way to put it.
That's a game changer.
Mm.
But before we get ahead of ourselves, let's take a step back and dig a little deeper into how BitNet a4.8 actually achieves this incredible efficiency.
All right, let's do it. So one of the key innovations with BitNet a4.8 is it's not just applying this hybrid quantization and sparsification like across the board.
Right, not a one-size-fits-all approach.
Yeah, they're tailoring the balance between precision and efficiency for different parts of the model.
That makes sense because different parts of the model probably need different levels of precision.
Exactly. It's almost like having a specialized toolbox where you choose the perfect tool for each specific job.
So they're really taking the time to fine-tune the optimization for each component.
That's right.
But how do they actually determine which parts of the model need which level of precision?
Well, it's a delicate balancing act.
Yeah, I bet.
They analyze the structure of the model and the specific tasks it's designed to perform.
So they're looking at the big picture and the detail.
Exactly. And for instance, remember that attention mechanism we talked about?
The one that acts like the AI's short-term memory?
That's the one they found that reducing the precision of values in that mechanism.
Saves a lot of memory.
Yeah, especially when dealing with longer sequences of information.
Makes sense. It's like deciding which clothes can be folded more compassionately without getting wrinkled.
Perfect analogy.
You wouldn't want to cram everything into the smallest packing cube possible if it meant ruining your favorite shirt.
Exactly. And this optimization of the attention mechanism is particularly impactful for tasks like language translation or text summarization.
Oh, right, because those involve processing large amounts of text.
Right. It's all about finding that sweet spot between efficiency and accuracy.
I'm starting to think about all the potential applications for this technology beyond just fitting AI onto smaller devices.
Yeah.
If we can make these models faster and more efficient, even on powerful hardware, the possibilities seem endless.
Absolutely. Think about the potential for personalized AI assistants.
Ooh, yeah, like a truly personal AI assistant.
Imagine a world where you have an AI that understands your preferences.
Learns from my interactions.
Exactly, and provides tailored recommendations, all while running locally on your phone, keeping your data private.
That's amazing. It's like having your own personal Jarvis from Iron Man,
Uh-huh.
but without having to build a multi-million-dollar suit.
Mhm.
And it's not just about personal assistance, right?
Right.
You mentioned healthcare earlier. Could you elaborate on how one-bit LLMs could revolutionize that field?
Sure. Well, imagine a world where healthcare providers could use these AI models to analyze medical images
That would be huge.
or predict potential health risks or even personalized treatment plans.
And all of this can be done in real time, right at the point of care,
Exactly.
while maintaining patient privacy because the data never leaves their device.
Right. It's a game changer for healthcare.
It sounds like one-bit LLMs could truly democratize access to powerful AI,
I think so.
making it available to everyone regardless of their technical expertise or access to fancy hardware.
That's the goal.
But is this all just hype, or is this really the future of AI?
It's definitely not just hype.
Right.
Microsoft Research truly believes that one-bit LLMs have the potential to become the new standard for AI computation,
Wow, so a real paradigm shift.
potentially paving the way for a whole new generation of intelligent applications.
They are both powerful and accessible.
Exactly.
So we're not just talking about incremental improvements
Yeah,
here.
this is a whole new way of thinking about AI.
What an exciting time to be alive.
Yeah.
But I'm curious, what's next for Microsoft and their BitNet architecture?
Well, their research is ongoing, and they're exploring many different avenues to further optimize and develop this technology.
I can imagine.
One exciting area they're focusing on is the development of specialized hardware.
Specialized hardware.
Yeah, specifically designed to accelerate these one-bit computations.
So instead of trying to run these models on general-purpose hardware,
They're building custom-designed systems from the ground up.
That sounds like a huge undertaking.
It is, but they believe it's essential to unlock the full potential of one-bit LLMs. Remember those computational bottlenecks we talked about earlier?
Oh, yeah. I remember.
Imagine having hardware purpose-built to handle those calculations with incredible efficiency.
So they're building hardware that's tailor-made for one-bit LLMs.
Precisely. It's like designing a race car specifically for a particular track. You're going to get much better performance than trying to race it on a regular city street.
Makes sense. So it's not just about making the AI smaller and more efficient, but
Yeah.
also about building the right hardware to support it.
Exactly.
And is Microsoft working alone on this, or are they collaborating with others?
They're collaborating with hardware manufacturers to explore these co-design possibilities.
It's a joint effort.
By tailoring the hardware to the specific needs of one-bit LLMs, they believe they can achieve even greater gains in efficiency and performance.
So it's a two-pronged approach: optimize the software and design specialized hardware that complements it.
That's right.
What an incredible synergy. But what about the everyday developers who want to experiment with this technology?
Good question.
Is Microsoft making one-bit LLM accessible to them as well?
Absolutely. They're committed to making this technology as widely accessible as possible.
That's great to hear.
They're developing user-friendly software tools and libraries to help developers build their own applications using one-bit LLMs.
So they're not just building the car. They're paving the road
Right.
and providing the roadmap for others to follow.
That's a great way to put it.
That's a truly holistic approach, addressing every piece of the puzzle to ensure one-bit LLMs reach their full potential. But before we wrap up, you mentioned earlier the potential for enhanced privacy with these on-device AI models.
Right.
Could you expand on that a bit more?
Sure. One of the biggest concerns with traditional AI models is that they often require massive amounts of data to be sent to the cloud for processing.
And that raises all sorts of concerns about data security and privacy.
Exactly, especially when you're dealing with sensitive information like medical records or financial transactions.
It's like handing over your most valuable possessions to a stranger and just hoping for the best. You never really know what could happen to that data once it leaves your control.
Exactly. But with one-bit LLMs, the processing happens right on your device.
So my data never has to leave my control.
Right. It's like having a personal vault for your data where you hold the key.
That's a powerful image.
Yeah.
And it sounds like this shift towards on-device AI processing could have a profound impact on a whole range of industries, particularly those that handle sensitive information. Can you give us some specific examples?
Sure. Well, imagine a world where healthcare providers can use these AI models to diagnose diseases and personalize treatments without ever having to send patient data to the cloud.
That would be a game changer for patient privacy.
Or think about financial institutions using AI to detect fraud and prevent identity theft, all while keeping your financial data secure and private.
So many possibilities.
That's exactly. And it's not just about security and privacy on device processing, also offers a whole host of other advantages,
Like what?
such as reduced latency, improved reliability, and increased accessibility for people in areas with limited internet connectivity.
So it's a win-win all around. You get more powerful, AI-enhanced privacy and a whole host of other benefits. It almost sounds too good to be true.
I know, right?
But I know there must be some challenges that still need to be addressed. What are some of the hurdles that researchers are still working to overcome?
Well, one of the main challenges is that the field is still pretty new. We're just beginning to understand how to design and train these models effectively.
Right, it's still early days for one-bit LLMs.
Exactly. Remember how we talked about packing a suitcase efficiently?
Yeah, with sparsification and quantization.
Right. Well, figuring out the optimal way to apply those techniques.
It's like finding the perfect packing technique.
Exactly. It takes practice and experimentation to get it just right.
So it's not just a matter of shrinking the model.
No.
It's about shrinking it in a way that preserves its performance and accuracy.
Precisely. And as with any emerging technology, there are always unexpected obstacles that pop up along the way.
Right, there's always something new to learn.
Exactly. But the progress we've seen with BitNet a4.8 is really encouraging. It shows that we're on the right track.
And it's inspiring others to join the effort.
Absolutely.
Speaking of hardware, we talked about the idea of specialized hardware designed for one-bit computations.
Yes.
Can you tell us more about what that might look like and how it could further revolutionize this field?
Okay, so imagine computer chips that are specifically optimized for these one-bit operations.
Oh, wow, custom designed chips.
Yeah, these chips could perform these calculations with incredible speed and efficiency.
And using way less power than traditional hardware.
Exactly. It's like having a superhighway dedicated solely to electric cars.
I love that analogy.
They can zoom along without being slowed down by traffic from gas-guzzling vehicles.
So instead of trying to force these one-bit models to run on hardware
Yeah.
designed for a different type of computation.
We're creating a whole new infrastructure specifically for them,
And that's what you call co-design, right?
exactly where hardware and software are developed in tandem.
That's really cool. And this co-design approach could unlock a whole new level of performance and efficiency for one-bit LLMs,
For sure, we could see AI models that are not only smaller and faster,
but also far more energy efficient.
which is crucial for extending battery life on mobile devices and reducing our overall carbon footprint.
It's amazing to think about all the possibilities.
It is.
But this shift toward one-bit LLMs and specialized hardware,
Yeah.
what does it mean for the future of traditional AI models and the massive data centers that power them?
That's a great question. And while I believe 1B LLMs have the potential to revolutionize many aspects of AI,
Yeah.
it's important to remember that traditional models still have their place.
Right, they're not going away anytime soon.
Exactly. They excel at tasks that require massive amounts of data and computational power.
Like training those huge language models.
Right, like the ones that can generate human quality text or complex simulations for scientific research.
So it's not necessarily a case of one replacing the other,
No, I don't think so.
but rather a broadening of the AI landscape,
I think that's more accurate.
with different types of models and hardware coexisting and complementing each other.
Exactly. It's all about choosing the right tool for the job.
Makes sense. So for tasks that can be handled efficiently on smaller devices with one-bit LLMs,
We'll see a shift towards on-device processing.
enhancing privacy and accessibility,
Right, but for those tasks that require the raw power of traditional models.
those massive data centers will continue to play a vital role.
Exactly.
It sounds like we're entering a new era of AI,
I think so.
one where we have a diverse toolkit of models and hardware at our disposal, allowing us to tailor our approach to the specific needs of each application.
Precisely. And that's what's so exciting about this field. There's so much room for innovation and exploration.
It really feels like the possibilities are endless.
They really are, and it's impossible to predict all the amazing things we'll be able to achieve with AI in the years to come.
Absolutely. It's like we've just discovered a whole new continent and we're just beginning to explore its vast potential.
Well said, and as with any great exploration, there will be challenges along the way, unexpected discoveries, and moments of awe and wonder.
For sure, it's going to be an exciting journey.
It is, but one thing's for sure, the future of AI is bright, and one-bit LLMs are lighting the path toward a world where intelligent technology is more accessible, more efficient, and more beneficial to everyone.
What an inspiring way to end our deep dive into the world of one-bit LLMs.
Thanks for having me. It was a great conversation.
Thanks for joining us and sharing your expertise on this fascinating topic.
My pleasure.
And to our listeners, thanks for joining us on this journey of discovery. We hope you're leaving today feeling as inspired and energized about the future of AI as we are. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of what's possible.